Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate in the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So I also got my Bachelor's of Science at this institution as well in the Pharmaceutical Chemistry program. So today we're going to go over some commonly asked questions in chemistry at the high school and college level. If you needed any help with homework or tutoring, then check out the links in the description below. So now I'm just going to get started on our set of questions for today's session. Okay, so our first question asks, what is a chromic acid? So chromic acid has the following chemical formula. H2CrO4. So basically, if I were to write these out into ions, we'd have 2 H plus ions and 1 CrO4 2 minus, which is the chromate ion, and it has a -2 charge. So let me just write out its structure right down here. So there's a double bonded oxygen on the chromate, or the chromium, and there's a second one at the bottom here. There's an OH group, and another OH group on the left side. Yeah, that's all there is to it. Let's see what our junior tenure said. So chromic acid with chemical formula H2CrO4 is a strong acid because hydrogen ions completely dissociate in the solution. It is toxic and should be made in small quantities and stored in a labeled glass container with a stopper. Proper safety equipment should be worn when preparing chromic acid. It should be prepared in a ventilated room, preferably in a fume hood. To make chromic acid, sodium dichromate or potassium dichromate is mixed with a little water to make a paste. Adding sulfuric acid to the paste while stirring makes chromic acid. So this was well explained. This solution is correct. Okay, so now let's move on to question number 2. Question number 2 is asking, how do you convert gallons to quarts? So first, let's recall the conversion factor. 1 gallon is equal to 4 quarts. So I'm just going to write out an example of converting gallons to quarts. Let's say how many quarts are in, let's just make up a number, like 57 gallons. So I'm just going to write down my unknown, x quarts over 57 gallons is equal to my conversion factor, 4 quarts over 1 gallon. So now I'm just going to solve for x by multiplying both sides by 57 gallons. And you know if you did it right, if your gallons should cancel out, and you're left with a value in quarts. So basically, this is 57 times 4, which is 228 quarts. Okay, so let's see what our junior tutor said. They simply just said 1 gallon is equal to 4 quarts, which is correct. Okay, so now I'm going to move on to question number 3. What is delta G? This is a good question. So delta G stands for the change in Gibbs free energy. And what this means is that it is the max amount of non-expansion work that can be extracted from a thermodynamically closed system. So another interesting thing about delta G is that it can also be used to describe the spontaneity, IETY, of a reaction. So I'll just say how. When delta G is a negative value, this means that the reaction is spontaneous. When delta G is equal to 0, the reaction is in equilibrium. And also when delta G is positive, this means our reaction is non-spontaneous. Yep, so the way we can calculate delta G is by using the following formula. So delta G is equal to delta H minus T times delta S. So the values here, I will also define. Delta H is the change in enthalpy. So basically this is like the heat of the reaction. And also delta S, this is the change in entropy. So entropy kind of describes the randomness of a system. When a system increases in entropy, then it becomes more random and more disordered. When it decreases in entropy, then it's less random. Okay, so let's see what our junior tutor said. The Gibbs free energy G is a thermodynamic potential that can be used to calculate the maximum of reversal work that may be performed by a thermodynamic system at a constant temperature and pressure. The change in delta G is equal to the sum of the enthalpy plus the product of the temperature and entropy of the system. Oh yeah, I should also label T as temperature just to make things. T is temperature. And entropy of the system. It is used to describing the spontaneity of a chemical reaction or process. When delta G is positive, the reaction is non-spontaneous. So for example, the input of external energy is necessary for the reaction to occur. When delta G is negative, the reaction is spontaneous. So that means it will occur without any external energy input. And then when delta G is 0, the reaction is in equilibrium. So this solution is correct. Okay, so now let's move on to question number 4. What does percent composition tell you about a molecule? Well, I'll write down the definition of percent composition. And just simply putting it, it is the percent of the total mass of the compound that is due to that one component. So I'll give the like the equation that can be used to calculate percent composition, just so that it's easier to explain basically. So I'm gonna call it mass percent is equal to the mass of your like desired component. So it can be like an element or it can be a whole compound. But basically it's the mass of that component divided by the total mass times 100. Okay, so that gives you percent composition. So let's see what our junior tutor said. Percent composition tells you which types of atoms or elements are present in a molecule and their levels. Percent composition can also tell you about the different elements present in an ionic compound as well. Okay, so this solution is correct. I'm also just going to add the mass percentage equation. Okay, so I said that the mass percent is equal to the mass of the component divided by the total mass times 100%. Okay, so now let's move on to question number 5. How many pints are there in a quart? Okay, so basically there are 2 pints in 1 quart. So I can write out an example question. Okay, so I'll just ask how many pints are in, let's say, like 26 quarts. Okay, so all we have to do is do x pints divided by 26 quarts is equal to our conversion ratio, which is 2 pints divided by 1 quart. Okay, so now we just have to solve for x. So let's multiply both sides by 26 quarts. And you know you did it correctly if your units should cancel out nicely. So we're trying to get rid of our quarts, and we want an answer that is in pints. So basically it's 2 times 26, which is 52 pints. Okay, so let's see what our junior tutor said. There are 2 pints in a quart. 1 US pint is equal to 473.176 milliliters. 1 US pint divided by 473.176 milliliters times... Okay, so they also put how many mils are in a quart as well. So 946.35 mils in 1 US quart. And they got 2 US pints over quarts. They also have the value of if you lived in the UK, but you still end up getting 2 pints in a quart no matter what region you're from. So this solution is correct. Okay, so now let's move on to question number 6. What is a dehydration reaction? First, let's analyze the word. You'll notice that it has a suffix that says hydra, so you know it has something to do with water. And then there's a prefix of D, so it's kind of like water removal. But most people know what dehydration means. But basically, in chemistry, it's a reaction where 2 molecules condense together and then water is formed as a byproduct. Okay, so I'm just going to give an example. Using some amino acids. So all amino acids contain an amine group attached to a carbon that has a side group that makes it unique. And then it also has a carboxylic acid functionality as well. So this is an example of one amino acid. And then on the right, I'm going to draw a second one. So it's going to have the same Let me draw it like this. It's gonna have the same structure with a carboxylic acid group and an amine, but the only thing that sets them apart is that they have different R groups. So let me just also put my hydrogen. And then I'm going to note this R group as R prime. Okay, so now in a dehydration reaction, I'm just going to circle where our molecules come together and water can be formed as a byproduct. So now our final product looks like this. Oh, sorry. Oxygen is now gone. So this is how biochemists would combine two amino acids together. Now, of course, I'm also going to write down our byproduct, which is the water molecule. Okay, so let's see what our junior tutor said. A dehydration reaction is a conversion reaction that involved the loss of water from the reacting molecule or ion. This reaction is between two compounds and it always has water as one of its products. A dehydration reaction is the same as a dehydration synthesis. A dehydration reaction may also be known as a condensation reaction. But more properly, a dehydration reaction is a specific type of condensation reaction. Chemicals commonly used as dehydrating agents include concentrated phosphoric acid, concentrated sulfuric acid, hot ceramic, and also hot aluminum oxide. When dehydrating alcohol, the alcohols typically undergo a 1,2 re-elimination reaction to generate an alkene and water. I think they just mean elimination reaction. Nonetheless, this solution is still correct. Okay, so now let's move on to question number 7. What is the molar mass of oxygen gas? Okay, so first let's write out the molecular mass of just a single atom of oxygen. So this value can be found on the periodic table, and it's just 16.00 grams per mole. Oxygen gas, however, is O2. So therefore, the molar mass of O2 is equal to 2 times 16 grams per mole. Then we get a final molar mass of 32 grams per mole. Okay, so let's see what our junior tutor said. Gases are usually characterized as diatomic atoms. This means that there are 2 atoms present. So for oxygen gas, the formula will be O2. To solve for the molar mass, we must multiply the atomic mass of the element to the number of atoms. Oxygen has an atomic mass of 16 grams per mole. Solving for the molar mass will result in 32 grams per mole. So this solution is correct. Okay, so now let's move on to question number 8. What is the trend of the value of electronegativity on the periodic table of elements? So that is a good question. But first, I will define what electronegativity is. So basically, it is the strength of an atom to attract electrons. So the trend for electronegativity values increases from left to right. And then bottom to the top. So for example, let's look at a fluorine atom. I'm gonna draw out its valence electrons. This is really bad. 1, 2. And you can see, I should draw it on this side. You can see that fluorine almost has a full octet, and all that's missing is a single electron. So since fluorine really wants to gain an electron, this means that its electronegativity is a really high value. Okay, so now let's say it gained its electron and it now has a negative charge. Okay, so I just said fluorine almost has a full octet, therefore it is very high in electronegativity. And if you look to the left here, the junior tutor included the trends, and fluorine is right at the top here. So let's see what they wrote. Electronegativity is defined as the strength of an atom to attract other electrons. The stronger the electronegativity, the attractive force is stronger and can even steal electrons from the atoms that have low negativity values. The value depends on the size of the atom. The less the distance from the nucleus of an atom to the electron, the stronger the attraction force. Thus, atoms have the highest electronegativity compared to the bigger atoms. This trend on the value of electronegativity can be seen as this, and then they just show us the trends. Okay, so this solution is correct. Okay, so now let's move on to question number 9. Describe a nonpolar covalent bond. Okay, so let me just write out the definition for covalent bonds in general. A covalent bond is between two nonmetals and it also involves the sharing of electrons. Okay, so now that we know this, there are two main types of covalent bonds. The first, which I'll answer in the question, is the nonpolar covalent bond. So when you have a nonpolar covalent bonds, this is when the two atoms have an equal or similar electronegativity values. So I'm also going to pull up the electronegativity chart. So over here are all the different elements and all of their corresponding electronegativity values. So for example, nonpolar bonds are between atoms that are the same element, so like nitrogen and nitrogen. Obviously, they have the same electronegativity, so this is an example of a nonpolar bond. But also, let's look at the carbon and hydrogen bond. We can calculate their difference in electronegativity just by using this chart on the left. So the electronegativity of carbon is 2.5, and the electronegativity of hydrogen is 2.1. So therefore, they only have an electronegativity difference of 0.4. So there's a rule of thumb when you want to double check whether or not a bond is nonpolar or polar. Basically, when the difference in electronegativity is from 0 to 0.5, this means that you have a nonpolar bond. So let me write out the opposite of nonpolar. The second main covalent bond is just polar covalent. And as you can guess, this is when two atoms have dissimilar electronegativity values. Dissimilar electronegativity values. Then this leads to a dipole moment. And its electronegativity difference range is around like 0.51, so like I guess above that, to around 1.69. So let's write out the example of water. So the water molecule is a polar molecule, and the bond between oxygen and hydrogen is also polar as well. So we can also calculate the difference in electronegativity for oxygen and hydrogen. So let's look at the chart on the left. The electronegativity of oxygen is 3.5. And the electronegativity of hydrogen is 2.1. So this gives us a difference of 1.4. And you can see that it fits in the range of the polar covalent bonds. But on a different note, we can also just quickly look at what an ionic bond is. So ionic bonds are between a metal and a nonmetal. So every time you see a metal involved in a bond, you already know that it is ionic. So an example of this would be like potassium bonded with fluorine. And basically the difference in electronegativity for ionic bonds are typically when they're greater than 1.7. So let's look at potassium and fluorine. The electronegativity of Kf. Potassium has an electronegativity value of, where is potassium on here? Okay, yeah, 0.8, and fluorine's is 4.0. So I'm going to do 4.0 minus 0.8, which is very high, 3.2. So since this difference is very large, we already know that this is an ionic bond. Okay, so let's see what our junior tutor said. A covalent bond is a chemical bond formed from the sharing of electrons between two atoms. This bond is formed between two nonmetals. A nonpolar covalent bond is a type of covalent bond formed when the two atoms have equal electronegativities and thus have equal sharing of bonding electrons. Examples of compounds with nonpolar covalent bonds are diatomic molecules such as H2, Cl2, and O2. Yep, so this is correct. Okay, so now let's move on to question number 10. What is the molar mass of water, H2O? Okay, so let's just draw its structure. So first, I'm going to write down the molar mass of hydrogen, which is just found on the periodic table, 1.01 grams per mole. I'm also going to write down the molar mass of oxygen, which is just 15.99 grams per mole. If I wanted to calculate the molar mass of H2O, all I have to do is multiply the molar mass of hydrogen by 2, since there are 2 atoms of hydrogen in a molecule of water. And then I'm also going to add the molar mass of oxygen, which is 15.99. So when we add this all up, we end up getting 18.02 grams per mole. Okay, so let's see our junior tutor's answer. In definition, the molar mass is the mass of a given chemical element or chemical compound in grams, divided by the amount of substance in moles. The molar mass of a compound can be computed using a periodic table by adding the standard atomic masses in grams per mole of the individual atoms or elements. It is used to compute for the number of moles of a certain compound to give its mass. To compute for the molar mass of water, we need to get first the individual atomic masses of each element. Remember that for every 1 mole of H2O, there are 2 moles of H and 1 mole of oxygen. Therefore, we need to multiply the atomic masses of hydrogen and oxygen to 2 and 1 respectively. So you can see that they did that and got the total molar mass of water, which was 18 grams per mole. So this solution is correct. Okay, so now let's move on to question number 11. So here we have another molar mass problem. What is the molar mass of HCl? And so again, I'm going to write out the molar mass of hydrogen, which is 1.01 grams per mole. You find these values on the periodic table. I'm also going to write down the atomic mass of chlorine, which is 35.45 grams per mole. So if we look at HCl, there's only 1 atom of hydrogen and 1 atom of the chlorine. So therefore, all we have to do is add these two values together. And we get a final molar mass of 36.46 grams per mole. Okay, so let's see the answer from our junior tutor. Step 1, determine the atomic weights of each element in the given compound. Hydrogen 1.008 grams per mole and chlorine 35.45 grams per mole. Step 2, since there are only 1 hydrogen atom and 1 chlorine atom in HCl, add the atomic weights of these elements to get the molar mass of HCl. And they got 36.458 as well. So this solution is correct. Okay, so now let's move on to question number 12. How many cups are there in 1 quart? So to solve this, we need to know the conversion ratio of quarts to cups. So basically, there are 4 cups in 1 quart. I'll just also give like a conversion question example. So let's say, how many cups are in 67 quarts? So the first thing I would do is write X cups, since this is the units that I'm looking for, divided by 67 quarts. And then on the right side of the equal sign, I'm going to put my conversion factor, which is the 4 cups over 1 quart. And now I just have to multiply both sides by 67 quarts to solve for the X. So basically this is the same thing as 4 times 67, which is 268 cups. Okay, so our junior tutor said there are 4 cups in 1 quart. So converting cups to quarts, we use the ratio 4 cups to 1 quart. Yep, pretty much. So this solution is correct. Okay, so now let's move on to question number 13. What is the structure of caffeine? So everyone knows caffeine, which is found in coffee, keeps us awake, but no one really knows what its structure is. Basically, I'm going to draw it out. So it contains 2 main rings. Nitrogen groups on the first ring, with just like methyl groups sticking out. This carbon has a double bonded oxygen, and same with this. And then I'm just going to draw out the second ring, which is just a 5-membered aromatic nitrogen ring as well. Yeah, so that's all there is to it. Let's see what our junior tutor said. Caffeine is a central nervous system stimulant. Its mechanism of action is by blocking the adenosine receptors, preventing the feeling of drowsiness. Its structure is shown below. That was a great explanation, so I'm just going to say that. I don't know what that was. Okay, so now let's move on to question number 14. How many liters are in 2 liters? Or how many milliliters are in 2 liters? So to answer this question, we need to know how many milliliters are in 1 liter. So basically, in 1 liter, there are 1,000 milliliters. So if I wanted to solve for how many mils are in 2 liters, I'm going to show out all of the steps that I would do that, other than just multiplying 1,000 by 2. So let's say I'm looking for X milliliters in 2 liters. I'm going to put my conversion ratio on the right. So 1,000 mils over 1 liter. And now I'm just going to solve for X. So we multiply both sides by 2 liters. And you know you have done the question correctly if your units cancel out nicely. So our liters will cancel out. And we're left with our value in milliliters. So now it is just 1,000 times 2. 2,000 milliliters. Okay, so let's see the answer from our junior tutor. There are 2,000 milliliters in 2 liters. Explanation. A conversion factor is a ratio expressed as a fraction that can be used to convert between units. The conversion factor for milliliters to liters is 0.001. it means that there are 0.001 liters for every mils. Yeah, that's another way of putting it as well. So by using this conversion factor, the amount of milliliters in 2 liters is calculated as 2 liters times 1 milliliter over 0.001 liters is equal to 2,000 milliliters. So this is another approach. I personally don't like using like decimals. So, but this solution is still correct. Okay, so I think I have time to do one more question for today's session. Okay, so question 15, how would you convert liters to gallons? So the conversion factor of liters to gallons is that sorry, you can't see the screen right now. I don't know how long it's been like that, but the conversion factor from liters to gallons is in 1 liter there are 0.264 gallons. So I'll just make up an example question. For example, how many gallons are in 52 liters? Okay, so we can answer this question just by using X gallons over 52 liters is equal to 0.264 gallons over 1 liter. Okay, so whatever units I'm looking for will be in the numerator, and the units I'm trying to get rid of will be in the denominator. So now I'm just going to solve for X by multiplying both sides by 52 liters. Okay, so if you plug this in your calculator, you get X is equal to 13.728 gallons. And you know you did the question correctly if your units should cancel out, so our liters will cancel out, and we're left with gallons as our unit. So let's see what our junior tutor said. When converting units of measurement, you will be needing the conversion factor present between the units you are converting. Liters to gallons conversion has a conversion factor of 1 liter is equal to 0.264 gallons. You just need to multiply the given value of liters to the given conversion factor in a proper manner. So for example, we want to convert 5 liters of water in terms of gallons. We have 5 times 0.264 gallons divided by liters is equal to 1.32 gallons. So they had a separate example as well. On the conversion given above, take note of the positioning of the terms. The first term will be the quantity you want to convert. Next to it is the conversion factor. The conversion factor is arranged in such a way that the liters units will cancel out. You always want this to happen so that your resulting answer will be in terms of the converted unit of measurement you want. So that was very well explained. So I'm just going to say that this solution is correct. Okay, so I think that is all the time that we have for today. So if you like today's Q&A and you'd like to be notified of when we do this next, then please click the subscribe button and the notification bell below. If you wanted to submit a question of your own, then check out the links in the description below as well. If you like today's video, go ahead and give it a thumbs up and a comment, and don't forget to share it with all of your friends and classmates if they needed any help with chemistry. This has been Donna from OneClass, and I hope to see you soon. Bye.